Alright, so we're going to do something new today. We got our valve cover stripped. We ended up painting it. That didn't really work. The color didn't match the way I wanted it to. So we're going to actually go ahead and do some powder coating. Now, we got all the stuff that we need for powder coating. The problem is we still need to bake it. So what we're going to do now is actually make a custom powder coating oven. This needs to go up to 400 degrees for 20 minutes. So we need to make sure that our oven can actually get not only to 400, but potentially a little bit over that. So in case we get a paint that might need to go slightly higher, 415, or anything lower, we have a dial that we can adjust for that. So powder coat, the actual painting comes later. We're going to focus on the actual fabrication of our oven. So we've got some steel rod here. This we're going to bend into place to form our rack. Many of you that know my garage know it's pretty cramped. Normally there's a car parked here. So I've got like the lathe and all the other stuff kind of on this back wall here. I've got like welders on that wall. So we want to make sure that we build it so that we can actually roll it and perhaps tuck it away under one of the workbenches or something, and we can either bring it out, or we're not killing our back trying to move this thing around the garage. A couple of different casters from Lowe's. This piece is a piece of 22 gauge in a 24 inch by 24 inch. That's about 60 cm by 60 cm. So this is going to be basically for like the front door. So we're able to bend it or fold it in kind of whatever shape we want. And then we also got two sheets. This is cold rolled 16 gauge 24 inch by 24 inch. So basically the same size, but a little bit thicker. And this is going to be our walls, our back, our roof, and our bottom. So that way we have everything kind of structurally sound. Basically have enough steel to cut everything down to be just right. So we don't have a lot of room to screw up. But you know, I never screw up. I screw up every day. Funny enough, my wife has been complaining a little bit about the toaster oven that we have that I got when I was in college. And obviously, it's like a Walmart brand toaster. So she doesn't really like how she can't really bake in it. So we're going to go ahead and upgrade her toaster from somewhere. And I went ahead and stole the toaster here. So this is a Hamilton Beach toaster. It has a timer built in. And then it also has a dial indicator here for temperature, and we can go all the way up to 450. So this gives us the adjustability that we're looking for. We will have to calibrate it to make sure that that actually matches with the thermometer. You'll notice that it's actually domed, it's rounded, and the lid hinges, and it sort of slides over. And this is going to be kind of annoying to get around. Obviously, we're not going to be using most of this. We're going to strip it down, take it apart, and convert it into what we need. We might use some of these parts though. Now you're going to need a lot of tools for this as well. It's not just the materials. We're going to need a welder of some kind or some way to stick this all together. If you don't have access to a welder, technically you could probably get away with using rivets and perhaps a very, very high temp caulking in between there to really seal up the edges, but I wouldn't totally recommend that because you've got about 500 degrees of heat the closer you get to those burners, so you really don't want to be potentially starting a fire, so you got to be careful with that. The other thing to note is that once you do this to a toaster, once you bake these paints inside of the toaster, you can't use that toaster for food anymore. It's no longer safe. It basically lets off a lot of toxic fumes. So those toxic fumes are going to be inside the toaster, and you don't necessarily want to bake your bagels or your toast or any tiny cookies or whatever. So keep that in mind. You are basically destroying your toaster. You need ways to cut the steel. So if you have like some really good hydraulic shears, or if you have some air tools or some grinders, cut-off wheels, sawzalls, whatever, to be able to cut through all this stuff. And in a perfect world, I'll be able to put that glass door into the metal and actually have the glass door so I can see what's going on inside without necessarily opening up the oven, because obviously as soon as you open it, you let a bunch of heat out. So we want to try and keep this as self-contained as possible and have a little peephole and still be able to see everything. All right, first things first, let's clean up a little bit because this is kind of gross to work on.
So we went ahead and got our measurements, and we're basically cutting this in half and then cutting it in quarters for portions of it. So the 2 quarters will be the side walls, and this longer piece will be the base that we're going to use. And we'll just clean up our metal a little bit too. We don't want any sort of snags or anything like that. And we're going to be welding all of it later anyway, so clean edges help. Disassembly, it's going to be different for every toaster or every little oven that you're going to use out there. Basically, we're taking off all the paneling and trying to get to the burners. We're going to move the burner off the top and put it on the bottom. This way we can get more heat going through the toaster oven spread throughout the entirety of the toaster. So anything that we bake, like valve covers or intake manifolds or anything like that, will have even heat all around. So we're now building the base that's going to hold the second burner. So basically we chopped off the top section, which had mounts for the burner, and we're going to put that on the sides. We're just using some Tech screws right now to mount this the oven to the base so that we don't have it moving around. Now we're re-welding and configuring the brackets that are going to hold everything in place for the burner. I ran out of metal, so I stole my wife's cookie sheet to use as a wall to get a little bit extra space. She probably would have been less pissed at me if I just went back to Home Depot or Lowe's and bought some more sheet metal, but this was much faster. Now we're going to go ahead and take our back and our top we have folded in place, and we're just tacking everything in with our TIG welder right now. I figure this is a good practice for TIG stuff anyway, doing lots of little thin gauge metal. Really helps develop your feel for it and your skill. Now that everything is level across everything here, I'm going to tack it all in place. Just trying to get the structure here, making sure that we're not dealing with anything that's going to be too flimsy or too wobbly. We want to make sure everything's relatively stiff. And we got to cut a couple little patch panels here to adapt to the cookie tray, which is slightly wider than everything else on the top there. In order to do the door, we need to reinforce the top section. We can't really do anything with the flimsy steel, so we're putting in a 1-inch square tube, and we're just going to go ahead and do a bunch of light little tacks here and get our wall in place. When you're dealing with really thin metal, it does have a tendency to distort. So when we're dealing with the thinner 22 gauge stuff, we're being really, really cautious with our heat inputs, and we're moving and welding in kind of as much spacing as we can require so that we don't have to warp anything. I do warp some stuff later. You'll see that pretty badly. Right now we're doing the door. Do my little This Old Tony technique for cutting steel. And here we're just going to be bolting in these brackets, just using some Tech screws to drill through and hold the hinges in place. The benefit of this is we can make or modify or change it, so that's why I didn't really tack weld it. Also, I didn't want to cut the zinc coating off and remove the corrosion protection that's there. In order to modify these clips, so these are all little push connectors, crimp-on connectors, and I remove the plastic most of the time, but in this case, because of the heat, we have to. And I have some high-temp wiring here that has a fiberglass sheathing that's good to, I think it's 600 degrees. And we're connecting our two burners in series, so just making a little coil loop there to get around the spacing part of it. The rest of the wire I'll measure out here is going to go to the far side, and we'll run it on the floor of the back of the burner, so that way it's not in the way of anything, and again, this wiring can handle the heat. On the outside, we're going to put our crimp connector in, connect it on both sides, and then we'll heat shrink over the connection. The intent was not to make it removable, but to make it be nice and insulated.
I'm pretty sure what's going to happen. I'm hoping it doesn't short out somewhere, because then the whole toaster will fail, and it's all made of metal, so that's bad. Let's start with the low temperature. That's off. I can hear the heating elements. Put up to 300 degrees. I see the panel at 250, 260, 270, 300, over 300! So yeah, that shit's working, which is great. I'm gonna go ahead and turn it off. So next thing, we gotta get this rust off from me handling it. Just scrape that off. We got some high temp heat paint that goes up to 600 degrees, which should be plenty since we're only going up to about 400, maybe 450 max. And then we need to cut a hole here for our window so we can see what's going on. Obviously the window is from our toaster. It is curved, which makes it a little bit more annoying. Basically we need to come up with a filler sheet here that's going to blend and merge those two together so we can see inside but not let heat out. Then the last thing is going to be to make sure that we have enough sealing that we're not going to just heat the crap out of the garage, but we're also going to be able to bake what's inside, hit those temperatures that we need and not release too much heat. Obviously this big flap right here is not all the way closed yet, so we'll need some sort of a latch there. We might do some high temp silicone seals on the edges, and obviously I need to patch in this corner down here.
Cutting our edges for the steel to make sure that we get the spacing filled for the door. We're really just roughing up what we can, and we're going to just try and tack all this in place. Now I ran out of gas on my TIG welder, so I have to use my MIG welder on the lowest setting, and my lowest setting, which only has 3 settings, is extremely high. So I am blowing through this stuff like nobody's business, so I'm going to warp the crap out of it, but I'll do my best. Now that we've got our doorway cut, we can get our window positioned here and start tacking it all in place. Now, like I said, these welds are going to be horrendous in this spot. I am blowing through it left and right. It is just terrible. But at least now that most of the welding's done, I can go ahead and cover up all the parts that I care about, that I want to keep the stainless finishes or electronics protecting any of that stuff, and I can go ahead and spray paint the rest of this with some high heat paint. Yeah, I got cocky. It's all over my face. Sucks. Now that we get everything off, our oven still works, and we're able to vacuum up any dust or cutting debris that's gone through our oven. And now we're going to make our rack. So the important part of this, setting it up so that I can stand it on its side and hang stuff from it if it's little parts, or I can lay it down just above the burners for something like a valve cover or a flange or pretty much any kind of main piece I can configure, throttle bodies, whatever. I can set it up on top of this rack and still let the heat be able to bake on it. So I've got plenty of clearance to work with almost anything above that. And as you see, the valve cover fits perfectly. One other thing, of course, we don't want the heat to soak through our steel. Obviously, steel is a very good conductor of heat, so we want to put some insulation here. I found this in the plumbing section. This is like for water heater tanks, that kind of stuff to keep it. And then we're putting some ducting tape to help seal the corners and keep it from rolling off or peeling off. But that's the main gist of it, is, again, trying to insulate so that that heat doesn't leak out. And of course, a huge thanks, a huge shout out to our Patreon supporters. If you're interested in the projects, if you're loving the way these builds are going and these little mini projects, be sure to reach out. Of course, subscribe here, hit the bell to receive notifications, and check us out on social media. We've got our Instagram, we've got our Facebook, we've got our email and our website, and of course the Patreon as well. Thanks, guys. Hope you enjoyed it, and happy modding.
Are you rallying your mini?
Actually, yeah.
Awesome! Fist bump.